Welcome to this presentation on multiple in, multiple out, or Mimo. This presentation will give you a brief overview of the Mimo technology and some of the other key technologies which make Mimo possible. Mimo technology can be used to help improve wireless access in a number of different applications. Today, many of us are using Mimo in Wi-Fi applications. Mimo can be used to help improve the efficiency and reach in Wi-Fi applications such as hotspots or within the home where you're using wireless connectivity. It can also be used to provide a wireless alternative to cable and DSL for last mile broadband access using WiMAX. Again, Mimo plays an important part. Mimo can also help improve the efficiency in providing high-speed mobile data and telecommunication services for 4G and long-term evolution, or LTE. It seems rather counterintuitive, but Mimo actually relies on lots of interference. That is, we don't want a direct signal path between the base station and the subscriber station. For Mimo to have full advantage, we need good diversity in the signal propagation. So anything which interferes with the signal path, such as buildings, natural objects, aircraft, people, cars, etc., are going to actually help in the overall efficiency and effectiveness in Mimo applications. So let's take a look at exactly how this Mimo technology works. So one of the key technologies that enables Mimo, as well as LTE or long-term evolution, which is being used in the next generation of cell phone technologies, is orthogonal frequency division multiplexing, or OFDM for short, which is a lot easier to say than orthogonal frequency division multiplexing. Basically, in traditional systems where symbols are being transmitted, a symbol, for example, is a piece of information, a relatively broad bandwidth is used for each one of the symbols, and each one of these symbols is transmitted typically sequentially for a relatively short period of time. If we look at how OFDM is used, we transmit multiple symbols in parallel, each symbol using a relatively very narrow piece of spectrum or narrow bandwidth. However, each symbol is transmitted for a much greater period of time. This has a major advantage. When receiving the signals, it's much easier for the receiver to pull in each one of the symbols. Even if the signal degrades somewhat, we've got a far better chance of pulling in one of those symbols due to the fact that each symbol is transmitted for a much longer period of time. This is very important when working in Mimo type environments.